In these problems, we are going to try to solve for x in these rational expressions. And if you have one that's set up like this, it seems like the right way to go about this might be cross multiplication. So I'd multiply x minus 7 times x plus 5 and set it equal to x plus 3 times x plus 4. So let's try that. Let's see, that would be x squared. I think that would end up to minus 2x and minus 35. And then over here we would get x squared plus 7x and then plus 12. So just foiling out these chunks here. Now, if we subtract an x squared from both sides, those would disappear. I could add 2x to both sides, and I would get negative 35 equals 9x plus 12. And then I could subtract 12 from both sides, and I would get 9x equals negative 47, and divide by 9. And we get x equals negative 47 ninths. And as I look at this number here, it's not a negative 3, it's not a negative 5, so it looks like it's going to be a solution that would not make this original expression be undefined in any way. So it looks like negative 47 ninths is our solution. Let's look at another one. This one's a little bit different. Now I've got x over x plus 4 minus 1/5 equals negative 4 over x plus 4. And these two denominators here stand out to me because they're the same, so I can easily add them. So I think that's probably what I would do. I would add 4 over x plus 4 to both sides. Now if I do that, on the top I would get x plus 4, and on the bottom, keep the same denominator, x plus 4. And then I could move this negative 1/5 over here by adding 1/5 to both sides, and you could get an expression like that, an equation like that. And hopefully this looks a little strange to you, because x plus 4 over x plus 4, well, that equates to the number 1, and 1 does not equal 1/5. And if you're thinking that, you're on the right track. This whole thing here, this whole equation doesn't make sense, and actually there is no solution that's going to satisfy this. So when you see 1 equals 1/5, you know that's not right, and you've got no solutions there. All right, let's look at one more. This one looks pretty complicated to start with. We've got x over x minus 4 plus 4 over x minus 2 equals this whole big thing, x squared over x squared minus 6x plus 8. And what I would suggest you do is start by factoring this quadratic over here. When you do that, you get x minus 4, x minus 2. And that should raise your radar, because look at what our denominators are over here for each of these terms, x minus 4 and x minus 2. So to be able to solve this problem most easily, what I think I would do is make all the denominators this one, x minus 4 times x minus 2. The way I would do that is multiply this one by x minus 2 over x minus 2. And I'd multiply this one by x minus 4 over x minus 4. When you do that, let's see, we would get x squared minus 2x over x minus 2, x minus 4, plus 4x minus 16 over x minus 2, x minus 4 equals x squared over x minus 4, x minus 2. Now, at this point, the denominators are all the same. So if you thought about multiplying the entire equation by the denominator, you can basically cancel it out. And then we can go forward with this expression, which is a little simpler. So I've got x squared minus 2x plus 4x minus 16 equals x squared. Now, I can subtract x squared from both sides. It would get rid of those. I think I'm going to add 16 to both sides to get something over here. So we've got 16, and then let's combine the like terms here. That would be 2x equals 16, or x equals 8. Now you might want to plug that back in just to check, although as I look at the denominators here, it doesn't look like that's going to make anything undefined. So this is looking good that x equals 8 is a solution for this rational equation. So that's a little bit of work with solving rational equations.